Next, we need to calculate SST, whereby SST is the sum of squares differences between individual treatment means and the grand mean. So this is the formula for SST, and this x bar j is the treatment means, and this is the grand mean, and this is the sample size. So using the example, the SST would be the x bar for type 1, 94.8 minus the grand mean, which is 110.45, and then you square it and then you multiply with the sample size, which is 5, and then go for the second type, x bar for type 2, which is 113.4 minus the grand mean 110.45, square it and then multiply with 5 because the sample size here is all the same, so it's going to be 5, 5, and so it's 5. The x bar for type 3, 126 minus the grand mean, square it, multiply with 5, and so on, and we add everything up for all the 4 types, and then we'll get the SST, which is the sum of squares treatment, 2517.75. Next, we need to calculate SSE, whereby SSE is the sum of squares differences between observed values and the means for their respective treatment groups. So this is the formula for SSE. So if you look at the simple version of it, it is simply summing Nj minus 1. So what is Nj? This is the sample size for each of the treatment, and then multiplying with the sample variance. Previously, we have calculated the sample variance. So this is the sample variance for type 1, sample variance for type 2, type 3, and type 4. And then we need to multiply with n minus 1. So for sample 1, size is 5. So 5 minus 1 is 4. So since all is using the same sample size, so we need to multiply 4. So once we have this, we add up and then we have the sum of squared errors. So to set up the Anova table, we have the first column, the source of variation. The second column is the sum of squares. So this is what we calculated just now, SST 2517.75, SSE 3423.20. So SS total is simply by adding up SST and SSE, and then you get 5940.95. For the degree of freedom column, so for this item, it is k minus 1. So what is k? K is the number of treatments. So there are 4 treatments, 4 types, and then 4 minus 1 is 3. So for degrees of freedom for error, this is n minus k. So we have n, the total is 20. So 20 minus k, 4 types, so you have 16. So basically when you add up, you get the degrees of freedom for this, for the row total is 19. So how do you get mean square for the column of mean square? So mean square basically is just 2517.74 divided by 3, and then you get this. And 213.95, you get it by 3423.20 divided by 16. So in hypothesis testing, the steps is H null, H1, level of significance, and we need to have the test statistic. So here, the test statistic will be a F stats, whereby it is the formula is MST divided by MSE. So from the table, F stats would be 839.25 divided by 213.95. So our F stats here will be 3.923. So this is the calculated F, or the test statistic for our hypothesis testing. So once we have a test statistic, it is always a need to find the critical value. So for our test statistic follows F distribution, so we need to find critical value from the F distribution. So for F distribution, it is a continuous and positively skewed distribution, and its values range from 0 to infinity. So in order to determine the critical value from the F table, we always need the alpha, the level of significance, and also V1 and V2. Or simply, this is the numerator degrees of freedom, and here is the denominator degrees of freedom. The numerator degrees of freedom would be 3 because we are dividing MST with MSE. So this is the numerator and this is the denominator. So degrees of freedom for numerator is 3, degrees of freedom for denominator is 16. So in order to find the critical value from the F table, it is F subscript alpha level 0.05, and we have V1 and also V2, which is 3 and 16. So from the statistical table, we are using the F distribution where alpha is 0.05. So this is the numerator degrees of freedom, which is 3. Then we go down until we find the denominator degrees of freedom, which is 16. So basically, this is the numerator degrees of freedom. This is the denominator degrees of freedom. So this is V1 and this is V2. So the intersection here would be 3.24. So since we get critical value is 3.24, so the decision is to compare the test statistic and the critical value. So 3.923 is larger than 3.24, so therefore we reject H null. So when we reject H null, meaning there is evidence to infer that the mean lifetimes of the hard disk is different between the 4 disk drive. So basically we're saying that the means among the type 1, type 2, type 3, type 4 is not statistically is not the same.